Hello and welcome to my SQL tutorial for absolute beginners. Before we are starting, let me give you some introductory words on SQL. SQL, short form for Structured Query Language, is the standard language to query and manage a database in a database management system, short form DBMS. Popular DBMS, by the way, these are just some examples, there are way more, are Microsoft SQL Server, Microsoft Access, Postgres, and MySQL, which is the database management system we are working with in this introduction, which comes with a very nice interface and is open source. So why should you learn SQL? First, it is highly in demand in data analytics, data science, all quantitative finance fields, and still in web development. But also it is extremely useful and powerful for private programming projects to efficiently store and play around with data. A recommendation, if you want to check out the powerful combination of Python and SQL, check out some of my videos, which I will link in the video description. I asked my community how SQL is pronounced roughly 1 year ago. These are the results. Just that you've heard about it, there's a very important and controversial discussion on the pronunciation. You need some prerequisites. You should have MySQL and MySQL Workbench installed on your system. I will link a video in the video description how to do that. In this video, you will learn all core fundamentals you will need to get started with SQL. And in future videos, we could query real or larger databases, writing more complex SQL queries. Okay, let's get started. What you're seeing here is the MySQL Workbench interface. Important for us for now is this part. This is the query editor. Here we can write SQL queries or SQL syntax in general. And here in this part, you see an overview of your current databases/schemas. In MySQL, and this is very MySQL specific, a database is the same as a schema. And inside a schema or database, you're storing tables. So the first thing we are going to do is to create a database or schema. And we can do that by typing in create. And important to note here is that SQL is not case sensitive, so it doesn't matter if you write create in uppercase letters. If you write create like this, you can write whatever you like. It is not case sensitive. So we are creating a schema by writing create schema and give the schema a name. And let's say we want to name our database or schema sales department. And here in this database, we simply want to store some sales data. So for instance, how many items or what revenue we made in a certain location. Something like that, just for an example here, right? So we are creating a schema sales department and click this lightning bolt here. And with that, you see that you're getting a positive feedback here. So a green check mark that this query has been executed. And with that, if you refresh this schemas overview, you see that we have a database sales department here. All right. To delete a schema, you can just use drop schema and then provide the schema name and click the bolt. And now we see that the schema has been deleted. Now, just to show you that a schema in the database is exactly the same, you can just use create database. Sales department is the exact same thing. So you see, we're getting a sales department database. Now, inside a schema or database, you have tables. For now, we don't have any tables here, right? So we want to create a table. And to create a table, pretty straightforward. You're just taking create table, give the table a name, but you have to provide in which schema you want to create a table. So you're taking sales department dot and then give the table a name. So let's just call it sales for now. And when you're creating a table, it's important that you name the columns which this table want to have. And you also have to provide the data type of the column. So it's not possible for me to cover every single data type of MySQL in this video, and it's not my intention. For now, I'm just showing you an example data type. So for the location name, so this is the name of the first column, we are taking a varchar of maximum length 50. So this is the most common data type for text values which are quite short. So for example, location names, right? And the next column should just be the amount or revenue, right? So maybe revenue is better. Let's take revenue. And this, I'm taking an integer value, so just a whole number, right? 1, 2, 3, 4, 5, and so on. Why am I doing this? Because a floating value comes with some unnecessary complicated things in MySQL. So for instance, you have to determine how many decimals you want to take. For now, we're just taking an integer value for simplicity here. So let's execute that. And again, we are creating a table in the sales department database, giving it a name sales, which has 2 columns, location name, and inside this column I can store text values up to 50 characters. And we have a second column, revenue, which takes integer values, so full numbers, as data. So let's execute that. And if we refresh that here, you already see that we have a table created, sales here, which has columns, location name, and revenue. Okay, so you can check that here, but you can also query the table. So you can just take select, and this is probably the most famous SQL query on earth. So even someone who has no idea of SQL knows probably this syntax, that is select star from and then the table name. And our table name is salesdepartment.sales. And this is simply, so this is pretty much straightforward. This is simply pulling all columns from this table. So select star from this table simply pulls all columns from this table without any restrictions. So I'm pulling the whole data from this table, which is, by the way, just as a side note, not a good idea if you're working with millions of rows. Then those queries could take hours. But for now, if I'm executing that, you see, so let's pull that a bit down here. You see quite nicely that we have this table, location name, and revenue. This table with columns, location name, and revenue here, right? And for now, this table is empty. We simply have the column names here. So we want to change that. We want to fill this table with data. So we want to insert data into that table. And to do that, we are using insert into, provide the table name where we want to insert the data into. And then you have to provide which columns you want to fill data into. And first one, we are taking our location name, this column. And second, we want to take the revenue column here. And now we are providing values. So we are typing in values. And here you are providing the values for the columns. So if I want to fill in, let's say, as a location name, San Clemente, very beautiful location in California. And I want to have the revenue, which my sale generated in San Clemente. I'm just filling in $20 was my revenue in San Clemente. So this is simply filling in San Clemente in this column and 20 in this column here. So let's execute that. And you see we're getting positive feedback here. And if we are executing the select statement again now, you see that we have data here, San Clemente and $20 revenue here in San Clemente. Right? So just some more details on the select statement. You can also pull one column here, right? So you can take location name, execute that, and you will get San Clemente here, right? You can pull location name and revenue and get those two columns, right? So select stars is just every column, but you can also specify those columns. Okay, now let's actually fill in some more data. So next we are going to insert more than one row here, right? And that's quite straightforward. You're just taking a comma here and pass a new pair of parentheses. So let's take, I don't know, Seattle, and then we made $50 revenue here. Let's say New York City, made $60 there, and what else? I don't know. San Diego, we made $10. So you see, straightforward. To fill in multiple values, you're just passing values, and then you take a set of parentheses containing the value for location name and the value for revenue. So if I would execute that here and select star again, you will see that I have San Clemente, Seattle, New York City, and San Diego, and values for that, right? Now, let's move on, filling in some same locations. So I want to have multiple San Clemente revenues because of course I could make 2 sales in San Clemente, I could make 3, 4, 5 sales in Seattle, New York City, 10 sales, and so on, right? I could basically make an unlimited amount of sales here. So I want to have new values here in San Clemente. Let's take 30, New York City, 20, San Diego, 30. Right, so that I just get multiple revenue entries for a location. So for instance, now I have 20 San Clemente, 30 San Clemente, or 10 San Diego and 30 San Diego. And now we want to take a look into querying. So we can use select star from sales department and only pull data which is fulfilling a certain condition. So for instance, I only want to have those rows which are in San Clemente, right? Or those sales which took place in San Clemente. So I can work with a where statement here. So I'm providing where and then the condition. So could be where location name is San Clemente, right? And if I'm executing that, you see that I'm only getting the entries where my location name is San Clemente, right? You can extend, so let's get rid of this for now. You can extend the where condition by another condition by simply using and after you've written where, and provide a certain a second condition. So for instance, I only want to have entries where my revenue is larger 20. So if I'm executing that, I'm only getting the entry in San Clemente where my revenue is larger than 20. So in this case, 30, right? Okay, so let's move on to updating values. So let's pull the data again. Select star from sales department sales. Now let's say, for instance, for Seattle, there was a wrong revenue entry and you want to correct this value of 50. So it was 40 instead. For that, you're using an update statement. And an update statement is working like that. You set the value, and then use a where statement to screen where you want to set this value. So you're taking update, then the table name, and then you're working with a set revenue, so the column you want to set equals to the value you want to set. Instead of, let's say, 50, I want to have 40. And then you're working with the where statement where the location name is Seattle. And also the revenue is currently 50. Before executing that, I would work with a select statement to make sure that you have this exact row. So you're just taking select star from sales department sales, where, and then you just provide this where statement, and just make sure that you are in the row you want to replace. In this case, you are, right? So we are going to execute this and get a positive feedback that the value has been updated. Just as a side note, sometimes you're getting an error that you are in save mode. That is also a MySQL specific. For that cases, you have to set the SQL save updates to 0, but don't forget to set it back afterwards. Instead of updating values, you can also delete values. So a delete statement is looking like this. You can delete all entries in the table by typing in delete from, then the table name. And if I would execute that, which I won't do right now, I would delete all entries from my sales table. So you also need a where statement here. So if you want to delete a particular row. So if you want to delete this 40 row, this statement would look like this. And always when you are working with delete statements, take a select statement and make sure to really get or grab the data you want to delete. So just believe me, this will save you some pain, right? So in this case, you are screening, okay, is this row? And then you execute this delete statement, which I won't do right now, but this is how you are updating and deleting values. So let's get rid of that all for now. And let's again take a look at our table. And now I want to show you some aggregation functions of SQL. So first of all, how do they work in general? So you can take an aggregation function like the sum and then provide the column name where you want to sum on. So in this case, I want to get the sum of the revenue here. With that, I just get the sum of this column here, right? And this will look like this. So I'm simply getting 210. So in this case, I'm just summing over the whole column here, right? But of course you can also just filter here, right? So where, let's say, location name is San Clemente, and with that you are only summing over those rows where you have San Clemente, and you're getting the sum of the revenue over San Clemente. What you're seeing here is that you're only getting the sum, right? You don't get the location name because you only selected the sum of the revenue. And select, as we learned, is only picking the columns you wanna show here, right? So if you wanna have the location name besides that, you have to select the column here, right? So you see the sum of the revenue of San Clemente is 50. Okay. And there are other aggregation functions like taking the average over San Clemente, just to give you some ideas. Now you can also sum over all location names by grouping. So let's take sum here again. then the revenue and the location name. And then we are getting rid of the where statement. So we are taking all location names and we are grouping by the location name. And with that, we are getting the sum of each location, right? As you see here. And if you are working in the fields I've mentioned in the very beginning, you will use that a lot. Okay, so that's it for the aggregation functions, but we will come to that a bit later on again. So for now, I want to create a new table. So I want to have a table. Let's go to our sales department sales table, and I'll explain you what I want to do now. So I want to show you the concept of bringing two different tables together. So you see that I have a location name and a revenue here. But let's say I have a second table where I'm storing the state those locations are in. So for instance, Seattle is in Washington, little geography lesson here. New York City is in New York, San Diego, California, San Clemente, California, and so on. So I want to have a second table to get the state names. So I'm going to create a table and call that, so in my sales department database, call that state and take a location name again, taking a varchar with 50 max length and also a state name with varchar 50 characters max length. So with that, I've created a new table here. So I have to refresh that. You see state and same procedure as before. We are populating the table. Let's get rid of all the syntax for now. We're just inserting into, then sales department state, provide the column names, location name and state name. And yeah, let's fill in some values. So let's take San Clemente, as said, is in California. So again, I'm just filling in a row San Clemente for location name and California for the state name. So if I'm executing that and query select star from sales department state, I will get this structure, right? Location name and state name. So yeah, let's take this for now. And we are going to take this table and I want to combine this table with my other table, with my sales table. So what is my goal from pulling this sales table? I want to have a column here which is telling me in which state that location is. Now, I should only get entries for San Clemente, right? Because San Clemente is the only one where I currently know in which state that is. So my database knows in which state that is. So to combine two tables, you're working with joins. And I think the most clear one is the inner join. So the inner join, if you inner join two tables, you're only getting the intersection of both tables. So in this case, if you are taking the state table and inner join it with the sales table, you should only get the San Clemente entries because they exist in both tables. So how does an inner join work here? Pulling select star from sales department sales, then perform an inner join and provide the second table name, so sales department state. And I also provide where I want to join on, and I want to join on the location name. So For joining on, I recommend to use a concept which is called aliasing. So you would join like this. You would provide the table, then the column name, and this is just too much code here, right? So you can just alias by using as and then sales. But I personally don't use as and just write sales. This is also working. This is the same. So you can use as if this is not intuitive for you, but I'm using it like so. I'm just providing the alias after selecting. So you can also do that here, state. But as said, if you don't feel comfortable with that, you can also work with as, right? So now I can just use the alias here, then take state location name, and this is how an inner join would look like. So with that, if I'm executing that, I'm getting a table like this, and let's understand that. So I'm getting only the San Clemente entries. Why? Because I performed the inner join, and with an inner join, I'm only getting the intersection between both tables. And as I know, I only have San Clemente in my state table. I'm only getting the San Clemente entries here, right? And as you see, I'm getting both tables. Here I have my left table, my sales table, and here I have my right table, my location, my state table. Okay. And what's important here is if you want to, you don't need those two location name columns, right? And if you pull the right columns here, you can make it more lucid. So let's say I just want to have location name, the state name, and the revenue. To do that, you have to understand that you cannot just select the column names here, because this column name, so if I would take location name here, this column name is ambiguous. So I can actually execute this here. So if I only want to pull the location name from this table, I would get an error here, and this is something like column location name in field list is ambiguous. Yeah. So this means it doesn't know which location name I want to pick here, right? So I have to determine from which table I want to take the location name. And it really doesn't matter in this case here, right? Because it's the same anyways. But I could take, for instance, sales.location name, and with that I would get only the query knows which column I should pick here, right? So how you can get a meaningful table would be to take the sales location name and then pick the other columns. You can just take them as they are without providing the table, as they're not ambiguous, right? You can just take a location name, state name, and revenue. Wait, you don't see the query here. Revenue. And with that, you're getting this beautiful table containing the entries which are in both tables, right? San Clemente in California and the revenue. Okay. Now let's take this to the next level by taking a look at the left join. But let's keep all columns for now. So what does the left join do? The left join is taking the entries from this table where you pull the data from and is pulling the intersection between those two tables here. So you're getting all data from the left table, this table, and the intersection of those tables. So if I would execute that, you see that I'm getting all my sales table data, and you see I'm getting null. Well, you see, because they simply don't exist in my right table. Okay. So you see only here, only those two rows here. And these are my intersections. So this is my inner join, But if I'm performing a left join, you see I'm also getting the entries from the left table. Vice versa for the right join. So in this case, that might be quite confusing. If I'm performing a right join, I'm only getting the intersection values again. Why? Because simply there is only Santimente, which exists in my left table, right? So this is why I'm getting the same values as in the inner join here. But if I would have values in my state table which don't exist in my left table, I would also get null values for the left table here. So let's actually do that. I think that's quite good to know. Let's just add something which doesn't exist in our sales. So for example, Houston and then Texas. So if I'm inserting that and perform this right join, you see what I just said, right? Now you are getting it the other way around as the left join here. And yeah, so just to give you an idea, I personally only use inner joins and left joins. So I never actually use right joins. So important are left joins and inner joins, and I hope I could make them clear. Okay, starting from scratch, let's create a schema or database, sales department. And in this schema, we want to create a table, which we are calling sales. And this table should contain a primary key. And a primary key is nothing else than a unique identifier. This is a column which can only contain unique values. So for instance, a number 1, 2, 3, 4, 5, 6, 7, and so on is a unique value, right? And we are calling this column ID, which is an integer, and a primary key can never be null. So we have to define not null here. And you can keep it like this, but my recommendation is to auto increment this value. With that, when entering new data into this table, you automatically get a new ID value. So meaning if I'm entering, and I will show you in some seconds, if I'm entering the first entry, I'm getting a 1 as the unique identifier or primary key column. And if I'm entering the next row, I'm getting a 2. So you would need to type that in manually when inserting value into that table. But if you write auto increment here, you don't have to fill in this value, so this ID value, when entering data. And that is the common way you do it. Now we are defining it as the primary key, so this ID column. And then we also define other columns, and I'm just taking one more column or two more columns here. The first one is the location ID, which is also an integer. And this location ID column is just containing a number. So let's say you made a sale in Santimente. This corresponding location ID for Santimente is a 1. If you sell in, let's say, Los Angeles, this corresponding location ID is a 2. So you only have to fill in integer values in your sales table. And with that, of course, you have a lot less data in your database, making it more efficient, right? Because otherwise, imagine you have millions of rows and you always have a Santimente value, so a text value in your table. That would be very inefficient. So you're just storing numbers for the sales entities you have. And we will create a second table where we match those location IDs. So where we say 1 is Santimente, 2 is Los Angeles, right? And we also need the revenue which is an integer value, as I said in the beginning, should rather be a float value than integer, but for simplicity we are taking an integer value here. So with that we have created the sales table with a primary key. And now first of all I'm showing you how this table looks like without data in it. So you see we just have an ID column, a location ID column, and a revenue column, right? And now I'm filling in data into this this table, and you will see what is happening with the unique identifier. So let's insert into sales department sales. Now we just have to provide the location ID and the revenue. So let's say we wanna take location ID and revenue, which we want to fill values into, and then provide 1. So we made a sale. So this is the value for the location ID. We made a sale in location ID 1, whatever that is. We will create this table in some seconds/minutes. And we made a sale of $20 here. So when we are inserting that and take a look at that table again, you will see that this is being auto-filled, right? This is being auto-incremented with each entry we are filling in here, right? And this is a unique value. This is always incrementing whenever you are filling a new sales entry into this table, right? And that being said, so let's also create a location ID of 2 here, and there we made $50. And if we are taking a look at that table now again, you see auto incremented ID, and we have a 2 here. So that's it for this table. And now we need the location table. So let's create it. And we want the locations table also with a primary key. So we can just take this syntax here, give the table a name, let's call that locations. And here we are also just taking an ID column as the primary key, so this will stay the same. And we just want to have as a column the location name, which is again a varchar length 50. Okay, and with that we are creating a table like this. And here you see again we have an auto-incrementing column as the primary key, the ID, and a location name. So let's insert some data into that. So we only need to provide the location name here, as again the ID value is auto-incrementing. And let's fill in what I said, so San Clemente for the first location. Oh, sorry. Okay, let's take a look at that table. So you see I have an ID here as my primary key of this table and the location name San Clemente. So if I'm inserting Los Angeles now in this table, you will see that I have my ID 2, which is Los Angeles, right? And if we take a look at the sales table now again, I know that I made a sale in San Clemente here and in Los Angeles here, because these values are mapped in the location or locations table. Right? Now, the problem with that is if I'm taking my sales table now and insert data into that with a location ID, which is not in this table here, so in the locations table, there won't be any error. So I could fill in data with an unknown location. So let's actually do that. Insert into sales department sales and provide a location of 3. So of course here location, ID and revenue, and then fill in a location ID of 3 and revenue of 100. If I would do that, this would work without any problems. So I'm getting a positive feedback here. So I have a value here, location ID 3 and revenue of 100. But where did this revenue occur, right? And this is a problem which you can solve using foreign keys. So a foreign key is a reference. So I'm connecting the sales table with the locations table. With that, I'm only making it possible to enter data into the sales table where I have a location ID mapped in my locations table. So for now, I'm just creating my sales table newly. I'm dropping it. You can also alter tables, which is not part of this this video, but you can do it with an alter statement as well. For now, I'm just dropping the table sales department sales. And now I'm creating the table sales department sales again with a foreign key. So this stays the same. Auto increment, primary key is still my ID column here. Then I'm taking my location ID, which is still an integer value. I'm taking my revenue, which is an integer value. And now I'm defining my foreign key. So I'm just writing foreign key and reference the column, which is my location ID. And this should reference to my locations table and then the ID column in this table. So with that, again, I'm creating the table you just saw, just with a reference to the location table. And whenever, and I will show you in some seconds, whenever I'm entering data into the sales table with the location ID not existent in the locations table, it wouldn't be possible. So if I'm executing that, I've created my table, looking exactly as before. And now, so let's take a look at the locations table. Now let's enter data. So we have San Clemente and Los Angeles. So if I'm inserting a value of 1 here, this will work because 1 is San Clemente in the locations table. Will work. If I'm taking a 2 here, that is Los Angeles. Will work. But now let's take an ID which is not in this locations table. So 3, we don't know where was the sale occurring. So if I'm executing that, which worked beforehand, right? But now with the foreign key, referencing my locations ID column to my locations table, this will run into an error and we will get the response: cannot add or update a child row, a foreign key constraint fails, right? So with that, you have a relationship between those tables and avoid wrong data entries. Very important foreign keys and not that hard to understand. And I hope I could make this clear. Now, let's play a bit around with that, with what we already learned, right? So my goal is, I will write that here. By the way, this is how you can comment in MySQL. I will want a table, get a table showing the location name and the summed revenue on this location. So let's take a look at the sales table again. Of course, we need to insert some data that this is making sense. So we are entering some more sales per one location. So for Santimente, we also have a 20. We have for Los Angeles, we have 150. Then again, Santimente 30. And that should be fine for an example, right? So let's execute that and take a look at the sales table again. Now you see we have 101, we also have 20 and 1, we also have 30 and 1, 50 and 2, and 150 and 2. And I want to have a table where I have my revenue, but also my location name besides that, right? I want to present my data to CEO, CFO, or whatsoever, or my colleagues. So they don't know what locations ID are about. They know what names are about. So let's solve that with what we already learned, using a join statement. And now it's important to understand that when you're using a foreign key, it doesn't make a difference if you're using a left join or inner join, right? Because the foreign key avoids that you don't have intersections between tables. So when I'm using those foreign key tables, I usually work with left joins. But as said, you can also work with inner joins. So I want to get a table showing the location name and the summed revenue on this location. So we are starting with pulling everything from my sales table, and we are aliasing that as sales. Now we are doing a left join on the locations table. We're calling that logs. On the location ID from the sales table, which equals to the locations ID column, right? So again, I'll show you the locations table. Here you see that my primary key is my identifier, right? 1 for San Clemente, 2 for Los Angeles. So we want to map, join that on the ID column in this table, right? And again, just to make this clear, we want to join this column on this table with the ID column on the locations table. So we can do that like this, and we'll get the table we want to pull, right? So we have a location ID and we also have a location name. Now we just have all entries here, right? So we just have 1 San Clemente, 2 Los Angeles, 1 San Clemente, 2 Los Angeles, and so on, right? Now, what do we have to do? We have to sum the revenue per location name, right? So we want to sum the revenue and group this table by the location name. With that, we are getting the sum revenue per location name. And as we have 2 locations, this makes sense, right? But this is for now meaningless because we don't have the location name besides. So we would need to pull the column location name as well. And with that, we already have what we wanted to achieve, right? The summed revenue on this location, right? So maybe it's more beautiful if you do it the other way around here. So you have San Clemente 150 and Los Angeles 200. Okay. So if you don't want it some revenue here and make it more meaningful, you can use an alias again. So let's structure that a bit better. So let's say total, okay, sorry. And then you have the total revenue here, right? So as you saw, you cannot alias using spaces here. That was the error. Now, okay, we have what we wanted to have. Let's also order this table by the total revenue just to show you what's possible. So I want to have the table ordered by the total revenue. And well, now nothing will happen because it's already ordered. But so this is ordered ascending. If I want to have it descending, I have the top location first. And yeah, that's it for using those tables, having primary keys and foreign keys. And this will also be part in the next video, right? So an SQL query can be way more complex and longer than this. And this is what I would like to cover in an upcoming video, where I focus on queries. So if you're interested in that, let me know. And for now, that's already it. Thank you very much for watching, and I'm looking forward to see you in the upcoming videos. Bye bye.